Hi, hello. I'm waiting for the signal, so that we'll be sure the stream is live. Yeah, it's there. Okay. I need to mention about the background noise, the floor noise, so it comes out of my aquarium. I can't do much with that. Let me also plug better microphone. I hope you can hear better and with less background or floor noise. Okay, the topic is the PyTorch, so the framework for AI programming. And I will just quickly introduce how to start using this with Python and how to configure, fully configure to use with C++. So it won't be real AI programming, but the introduction to do the setup. And for next streams, I will prepare some topic to show deep neural networks based on my knowledge. Yeah, so let me just quickly show the browser, because we start from the website pytorch.org, and from the get started. So right there, as I mentioned in previous streams, there is support for latest CUDA, the one that I actually have, and we will go through the operating system. So you need to pick your operating system. So I'm using the Linux, and I'm using pip package manager for Python, and CUDA 12.6, so PIP 3 is for Python 3, which is the latest and broadly used Python version. So we will run that command. And second one is if you go to C++/Java and the same CUDA version, over there under CXX11 ABI, which is Application Binary Interface, we will focus on the modern one, so C++17, as C++17 is supported by the fundamental AT Gen tensor that is the core of PyTorch. It has about 2.4 gigabyte of data. So actually I've prepared everything up front to go more smoothly with the stream. But if you start downloading that, you will need that actually. So not pre-CXX11 ABI, this is for some old machines, but we will focus on the modern C++, so actually 17, but it's called CXX11, and there is a 2.4 gigabyte package with the libraries and CMake configuration files that we'll be using. So on top of existing CMake files, we will build the one for our project again from the scratch. And actually there were a couple issues I needed to resolve. So actually, if you are advanced and you have it, so the time will be useless probably. But if you have no knowledge about PyTorch and you want to use with Python, it will be good short start to, and the very simple example to see that it's working. And second part will be for C++. So first we start with the Python, and for that I have open Visual Studio Code with the folder for stream number 5, and that will be used for C++. Okay, that will be used for C++. So actually, for Python, we will just use the console, and I will go to my catalog, which is AI. So in the AI, actually, what is there? So you can see that there is AI underscore nauka, which is, well, learning, let's say. I have the script, I have the zip file, and actually I extracted that, and there is libtorch. And you can see also pytorch.ipynb, which is Jupyter Notebook. It is interactive notebook, so you can actually do live coding, you can install new packages, and actually also present the results, and you can save it, and you can build a report out of this. So firstly, let me look to my notes. So actually, this is the command to create the virtual environment. So Python 3 M is for module virtual environment, and the name AI Nauka. So I did it before. So actually I will not, this is just one command, you need to run it, and after that there is the other command to activate the virtual environment. So the environment that will be not the system based, but it will be the environment based. So you can create multiple environments. It will keep the packages you are installing, so the versions will not collide if there are some dependencies. So this is the good approach actually to use the Python. I'm doing that way. So for anything I'm studying with the Python, which is very good for some revisions of topics. It's quite fast. It has very large number of libraries, tools, and one of this is PyTorch actually. So to activate the environment, we type source, and then we go to AI nauka /bin/activate. So you see that actually my command prompt is in the context of AI Nauka, and as you saw, to install Torch with Torch Vision and Torch Audio, you need to run this pip3 installation. So simply what you need to do to press enter, and you need to wait when it will be installed, so all dependencies will be installed as well. And second part that I'm using with Python is Notebook. So actually this is a Jupyter Notebook, and I can show you jupyter.org. So you can browse and you can check documentation how to use, but you will quickly try it actually, and yeah, it's very robust. So actually I have install with the command. I have Notebook install, and to use it there is command Jupyter Notebook. If you type that, it will start. It starts in my default Chrome, which well, I will not be showing, but I will open what that want me to wow, that's interesting. I haven't checked that. Okay, so maybe I will do that other way. So in my Chrome, oh, that's the issue. Set a password token. Password or token? I have no idea about password or token. If no password will configure, you need to open the server with the login token in the URL, pass it above. Okay. Okay. So okay, this is my Chrome with the folders which I wanted to hide, but well, it's faster. So actually, maybe I won't be losing time on configuring that. So yeah, so I've prepared the PyTorch, and actually you can go to new as well. If you go to the notebook, you are selecting the kernel. So I can say that there are also kernels for C++, so you can program in the browser in C++ as well. But this is not installed in this environment, which is virtual environment. So this virtual environment uses just Python. Okay. So actually, what we can do, we can check if we have a torch, which is import torch, and you can save, you can name it, and you can run it with the play. So the star is showing that it's running. If there are issues, it will be in the red. So actually you see there are no issues. And let's say we will print the information torch.CUDA is available. You can find it. You can find it actually without the print. It will. The last comment will be shown. So this is true. So we have CUDA, because PyTorch install with CUDA, and actually we can create the tensor with name x torch rand. So it will be tensor of 5 on 3 with random values. So it will be more the array. Okay, and print x. So we see that our tensor is 5 rows and 3 columns. So this is the matrix actually. What is the tensor? So tensor is a multilinear array. So actually the vector can be dot, can be column, let's say. So it is let's say in vector space it's let's say one line, to simply say, and matrix is like the square. So the tensor actually it is like it allowed to build with different sizes and with different directions, and this is the block that can concepts, and this is the main component of the neural networks and AI, simply saying. So actually that was quick introduction to the Python, how to use with Jupyter. Okay, so we can save that, and we can then go to shutdown. So we can shut down our notebook. Okay, I will close it now. We see that this is the notebook is closed, and now we can deactivate environment, and we will go out of the context of our virtual environment. And it is very recommended to use Jupyter because it allows with pip free install various components, and you can visualize data there. So pandas, matplotlib, numpy, and there is information actually that Torch is using the numpy. So if you go again to pytorch.org, pytorch.org, and PyTorch, another typo, pytorch.org, so you can find information that the numpy is used. And well, the one reason probably this is very advanced numeric library, which is built on top of with the C and Fortran, and actually this is the Python have the issue with the loops, and actually NumPy allow to do well different. Maybe let me quickly show that again. So source, activate Jupyter Notebook. Okay, it's open there. Let me open again the stream number 5 and import numpy as np. So we will run just that cell, and if you create array, np array, and that will be, let's say, 1 2 3 4 5 0 0 0 0, like that. If you run it, not much R. If we run it, and we will print X. Do I need to print X? Okay, and if you type something like X more than 2, so you will get the true false array, and actually you can combine that with some other array, let's say whole equals numpy array. So that will be 1 0 0 0 1 0 0. Yeah, like that. And if you use whole of X, will that work? Whole of X, whole of X more than 2. And just a second. No, how? Okay, oh, the size is not same. 1, 2, 3, 4, 5, 6, 7, 8, 9. 2, 3, 4, 5, 6, 7, 8, 9. So all of x2, will that work now? Zero, 0, 1. Well, this is maybe not a good example, but you can. So mainly I wanted just to show the concept to not use the loops. So using array and different ways allow to get the results without the loops. But yeah, maybe better example. It will be when there will be real AI programming. So, okay, again I will shut down and activate. We can close the browser, we can close the console, and we will go to the C++, which I'm fan of, and yeah, I wanted to show you also that libPyTorch can be used with C++, so it can have actually the full power of C++ and AI together. So again, that will be step by step since the beginning with solving the issues that I found, and I needed to find how to resolve that and so on. So CMake lists.txt. So this is our base, and actually what we need, of course, we need CMake minimum required, so will be version 3.18, let's say, and if not, there is fatal error. Okay, so then actually this is not well easy configuration. So actually in the H performance computing stream, the first one, I was showing how to install NVIDIA CUDA. So again, quickly, if you go there to the website and you will choose your environment, the architecture, distribution and version, local. So you need to actually go to the steps described there, and maybe being there, I will show what we use also. So NVIDIA CUDA, which is CUDA deep neural network, and you need to install that as well. So you need to go similarly to the website, and you need to choose distribution version and also install CUDNN. You see, this is quite big, and besides of that, there are two libraries which might be used. Actually, I've installed that already for sparse matrices. It's CU sparse LT, and there are very similar steps. You're going to, again, you are going and you are in console just copying with the copy paste pattern. You are preparing your environment. And last one, which is CUDSS, which also is for sparse matrices. NVIDIA CUDSS, again from NVIDIA developer. You're going to download for direct sparse solver library. Okay, download. Again Linux, again architecture, again distribution, again version, the file, and there are the comments, and it is just megabytes for that. Yeah, mainly that's it. So about 3 libraries together with and plus CUDA toolkit, which is the first one. So firstly the CUDA toolkit, then CUDNN, then CU sparse LT, then CUDSS, and you are home actually. Okay, and what issues I have? So I needed to set up NVTX3 directory, which is NVIDIA tools library, extension library. So there are some features, some annotations for the code and informations, and this is used also in the PyTorch. So if you install your CUDA, it will be mainly in USR local CUDA. So USR/local/CUDA. So to show some proof, LSL USR local CUDA, it points to CUDA /include. So this is same link. So NVTX3. So this is those are the header files for NVTX3, and we need to point that there. So CUDA include NVTX3. You can also download that, but it is with the CUDA. And the main one is Torch there. I'm not sure if this is capital or not. It's important, but you can try. I won't be trying at the moment. So my torch there is in home, Conrad, AI, lib, torch, and we need to point the CMake configuration file, and this is in the share CMake torch. Okay, and let's check if this is the correct one. list. Okay, we see there is torch config, so that one will be used. That's CMake configuration. Okay, so we will set also what we installed. So Cafe2. So libtorch C++ is based on the previous framework, which was merged. It was Cafe2, so that's why it referred to with one E. Cafe2 use CUDNN, we set true. and we need to copy that 1, 2, 3 times, and the other one is CU sparse LT. The one more is CU file, which I was not installing, and I'm not sure if I'm using that, but there was no issue. Another one is without the coffee, which was CUDSS. So that are additional configuration libraries, and then we can set project stream 5. We will use mainly CXS, but let's add CUDA as well, because in the future maybe we want to use it. And now we need to find package which is torch, and this is required. Required. So this is the find package. So actually it will be looking in a torch directory for the configuration. So it will use what is there, and we will just set additional CMake CXX flags, and we point there to our flags actually. So we will copy that if we will be using that, and the other one is but this is this inside the string. So our torch CXX flags. Okay, and just 3 lines left. So we need to create our folder for sources and our main.cpp, where of course we will use int, so our starting point to the main thread. Okay, that's for now. And then we add executable, which will be app, and our sources main cpp. And what we need to link? We need to link the torch. So target link libraries to our app and pre-configure variables so torch libraries. And actually, because we'll be using as I mentioned ATE in, and so the fundamental tensor, and that required C++ 17. So we will set property for our target app property CXX standard 17. Okay, let me open the terminal, and we need to create build. So we'll go to build, and with Ctrl Shift and P, actually because we have in our home directory the torch libtorch library in libtorch directory, and we need to point to our header files to make work in Visual Studio Code easier. So I will point and let me just quickly copy, you will see what I'm copying. So it's in my AI catalog, home directory AI libtorch and include, and another one is also to make work smoother. It's that one. So in addition there is torch, srcx API include, just to not add that in the main CPP in our case, or any other headers that you wanted to add. And let's now use the include, so ATEN, and we will use just ATEN. And if you go to the header, so you see that for Microsoft there is 17 version, but well, it's better to use the level one, and you see what is there as well, so we know that we are using that properly. And actually I need to show you that there was one issue that I needed to solve with help of with the websites when the same issue was described. So actually if I will go to libtorch, in the share, the CMake for Cafe 2, and in the public there is CUDA CMake. I will open that. Where is that? Open file. What? Share CMake Coffee to public. Oh, there is open. Okay. And there was one issue, and it is described in the internet. So actually in the line 135 I needed to command the Python interpreter to be used, and I replaced with the variable Python executable, because in other way there was issue failed to compute short hash for lib nvrtcso from the CUDA. So actually probably in your case, because this is the new version of PyTorch and I show it there a couple of years actually, so maybe this is the configuration, but it's very often, so you need to also change that manually in that file. Okay, so you see that. Okay, you see that. So this is the one change altogether with the configuration to work it smoothly. And I need to mention I have one issue with STM32 Cube IDE. So for production and maybe for your computer, PC or laptop, if you don't have STM32 Cube IDE, you will not have that issue. But because I have, so CMake is looking for finding packages also in STM32. I was not fixing that because the configuration I'm showing I've created just before the stream. So actually I've got materials to show. So I haven't resolved that issue yet, but there is the switch actually to not show that, and I will show that as well. So this is the full configuration, 18 lines with some spaces, and we have the main. So let's fill the main. So that will be also just example to have the proof that the configuration for the projects is prepared. So together with previous Python configuration for quick development, you can also use the full capacities of C++ with Torch library. So we'll use include torch/torch, and of course include IO stream. So we have the IO stream, and we create just two tensors, one for CPU, which will be in the host memory, and second one for GPU, which will be in the device memory. So let's start with torch tensor. Torch tensor, and that will be our also random tensor. Oh, sorry, that should be equal rand, and we are passing away 5 by 3. So 5 rows, 3 columns tensor, similarly as in Python. And let's see out we're not counting, we are printing. So this is the CPU example. Okay, and we will create a second version. So we'll check if there is torch CUDA is available, similarly as in Python. Okay, and we will print the information that we are doing CUDA. And actually the tensor will print the information that this is the real one. So torch tensor, actually we can use also 80 tensor, but let's use the torch tensor. Tensor, as it has the same construction. That will be GPU tensor, and there we will use actually 80 rand. So that will be our 5 on 3. And we will pass additional information, which is 80 K CUDA. Okay, so I will show you again. So you can choose between CPU CUDA and, well, FPGA, Meta, Vulkan, Metal, XPU, different architecture, different devices actually. So this is for some graphics, I'm not sure if this is addition to OpenGL, but you can run on different components of devices as well. But we are using the standard, which is CPU and CUDA on the GPU, because we have laptop with, and probably if you hear the noise, this is from the streamer. So yeah, I will try to make it better next time. Not sure when the next is. Okay, and we will just print. Oh, sorry, I was not count, but C out. out. And this is our GPU tensor. Okay, and one there, which is just the tensor. No issues? Or issues? No issues. Okay, so we are creating two tensors, one on the CPU and second one on the CUDA. So again, this is the configuration with pre-installed packages, with the links to the directories and so on. So let's check if the configuration works. CMake 2 dots. We are checking. We are compiling with GNU compiler and VTX3. Okay, so this is the one thing. It comes from STM32, and actually the warning is for project developers, so we can disable that with the flag warning nodef, and I will use that, but I could not find NVTX3, missing NVTX3, and so NVTX3. Okay, so it was NXTX, so this is not same, so each letter matter. Okay, so now CMake, but with the with additional flag to not show the developer issues, and this is just because it points to STM32Cube SLI. So actually I have that in my path, so for other environment that will be no issues. So again, maybe without that, configure again, so that will be one issue. Okay, but what we see there, so we have GNU compiler, NVIDIA compiler. We see that ABI is configured. We found CUDA, we found CUDA toolkit. We have P threads where we can use threads. So the NVRTC-SO short hash is found. The interpreter, which was the issue, there is no issue. There is my local issue for STM32, and actually maybe for some next streams we can do some STX for John. So actually I have the small microcontroller unit with two accelerometer with two gyroscopes and one, maybe I will show that, with one magnetometer from Bosch, and I will create some stream, but that will be different topics. So again, part one for STM32 and drone knowledge programming. But that I will be preparing next time. Okay, so we have that, and maybe I will delete that and show that with no warnings to. So we can use the flag warning nodef. There will be completely no issue. Found NVTX, found CUDNN, so the library, the sparse, which is opposite to dense. So sparse means there is a lot of zeros. So the matrices actually have a lot of zeros, which is not necessary to multiply by 0, or the worst case divide by 0. That is prohibited. There is divide by 0. There is no information about that. 0 divided by something have to have 0 again, but okay. And there is auto-detect CUDA architecture and NVCC. We see that our architecture is 6.1, which is compute 61, and found torch. Okay, so we now can call make to build actually the project. And we can run our app, and we see that there is CPU float type and there is CUDA float type. So 5 rows, 3 columns, 5. The values are random, so actually random generated, but size is same. Thank you. Have a good day.